All right, before we move to sigma notation with an infinite number of rectangles, we're going to need to look at some key formulas. Okay, so before we look at sigma notation, we need more complicated problems. We need to look at some key formulas. Okay, and one of those key formulas is the summation from I going to 1 up to n of the number 1. Okay, and what this means, for example, is 1 plus, so when I is equal to 1, you get 1. The sigma notation, this notation right here, sigma means sum, you put a plus sign, and then when I is equal to 2, you put a copy of 1, and then when I goes to 3, you get a 1, plus I goes to 4, you get a 1, and you keep going until you get to I is equal to n. Okay, and the question is, what does that add up to? As an example, we could look at the summation from I is equal to 1 to 6 of 1, and that would be 1 plus 1 plus 1 plus 1 plus 1 plus 1. This sigma notation is a nice condensed notation for something that you don't want to keep writing over and over again. But here are 3 ones and here are 3 more ones. And so that makes a total of 6 ones. Okay? So in general, right, the larger the number gets, like 200 of 1, so if you sum 1 from 1 to 200, you would get 200. I'll be back in a second. Alright, so in general, we have that the summation from I going 1 to n of the number 1 is equal to n for however many terms there, how many ones you had. Okay, so another key formula that we have is this situation. If you have the number 1 plus 2 plus 3 plus 4, right? What does that add up to? Okay, you could see that by adding them separately, you'd have 3. 3 plus 4 is 7, so that should add up to 10, right? Another way to write that would be in sigma notation. Sigma is going from 1 up to 4 of the number I. So I, when I is equal to 1, you get 1. Because it's sigma notation, you put a plus sign every time you change the I value. When I goes to 2, well, when I goes to 2, I is equal to 2. And then we go to 3 and then to 4, right? So we can see here that the summation from I equal 1 to 4 of I is equal to 10. And the quick way to see that is that 1 and 4, the ends add up to 5. 2 and 3 adds up to 5. And then there are 2 of those 5s, so that would be equal to 10. We'll do the general formula in a second. Alright, so as we try to extend this idea from adding up a bunch of numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way up to 10, for example. Sorry, I skipped too many steps there. Let's go from 6 to 7 to 8 to 9 to 10. So what would these numbers add up to? 1 through 10, right? That is the question. In sigma notation, this could be written much more concisely as the summation from I going from 1 up to 10 of the number I. Okay. Notice that 1 plus 10 makes 11. 2 and 9 make 11. So we have 11s. And because of the nature of how these numbers are written, we have 3 and 8. 4 and 7 make 11, 5 and 6 make 11, so that made 5 11s. So those numbers should add up to 55. Otherwise known as 11 times 10 divided by 2. Okay? So in general, we have this next most important formula that if you want to add up the numbers I going from 1 to n of the number I, then you will get the number, whatever that number n is, in this case it was 10, it would be 1 more than that number n multiplied by the number n divided by 2. So here we have two very important formulas that we're going to use when it comes to adding up an infinite number of rectangles. I goes from 1 to n of 1, adds up to n, and this other formula that if you add up the numbers from 1 to n of I, that will be n times n plus 1 divided by 2. So we will show how to use these two formulas in the next video.